Today we're learning about what's called a dot product of vectors. It's similar to multiplication with matrices, where you take the x component times the x component and you add it to the y component times the y component. Notice for a dot product that we get a number for an answer and not another vector. Two vectors are considered to be orthogonal or perpendicular if their dot product is 0. And the last piece that we'll be looking at today is how to find the angle between two vectors. You take the dot product of the two vectors and divide it by the magnitude of each vector multiplied together. Starting off with a basic dot product example, we have v dot w, which is 7 times -3 plus -2 times -1. -21 plus 2 gives us a dot product of -19. Our next example, we have a dot product with vector addition. We'll find the vector addition first, of course, order of operations, grouping symbols. This gives us I minus 10I, adding those x components, plus 4j plus 5j, adding those y components. We get a sum of -9I plus 9j. We'll then use that to find the dot product with v. Multiplying our x components, the x component of v is -8 times -9, plus the y component of v is -3 times 9. Gives us a dot product of 72 minus 27, or 45. Next, we're going to see if these two vectors are orthogonal or perpendicular. If they end up with a dot product of 0, then they are. Multiplying our x components together, 2 times 6, and adding our y components, 3 times -3, we get a dot product of 12 minus 9, or 3. The dot product is not 0, so they are not orthogonal. Finally, we'll find the direction angle between two vectors. First, we need the dot product for that numerator. 4 times 3 plus 3 times 5 gives us a dot product of 12 plus 15, or 27. We also need the magnitude of each vector. We'll start off with the magnitude of u. We'll have the square root of 4 squared plus 3 squared. 16 plus 9 is 25. Square root of 25 is 5. Finding the magnitude of v, we get the square root of 3 squared plus 5 squared. 9 plus 25 gives us a square root of 34, which cannot be simplified. Putting this together, we get the cosine of theta equals the dot product of 27 divided by the magnitudes multiplied together. In order to find theta, we're going to take the cosine inverse, so there's no need to rationalize this. We'll just punch it into our calculator. Cosine inverse of 27 divided by 5 times the square root of 34. This gives us a direction angle of 22.2 degrees. No, you tried today. I figured this was basic enough that we could be able to move into the assignment.